In section 6.4, we're going to talk about how to find inverse functions. Before we talk about finding inverse functions, it might be useful to talk about what an inverse function is, and even before that, what a function is. We've dealt with functions for a little while, but I don't think we've really defined them since maybe back in chapter 1. Remember, a function is a relation where each input has exactly one output. But let's look at that a little bit differently. A function is kind of like a machine. We choose some number to put into the machine. Maybe that's a 2. And that function tells us to do something to that number. It tells us to multiply it by this, add that, and it spits out some other number. So maybe we plug in a 2 and it spits out a 5. Or maybe we plug in a 4, and after we follow the directions of that machine, multiplying it, adding, squaring, whatever might be in that function, it spits out another number, right? And so we have these inputs, and our function gives us one output for each input, and those in general we called our x as our inputs and our y as our outputs. Well, what if we wanted the machine that would undo that function? What if we wanted a machine where when we put in a 5, we get out the 2, or if we put in the 8, we get out the 4? Whatever that machine is called the inverse function. So the inverse function we can write as, it looks like f to the negative 1, but it's not a negative 1 power like we've talked about. We would say that's the inverse of f. If we were to plug something into the inverse function, if we were to plug in an 8, that would spit out a 4. If we were to plug in a 5, it would spit out a 2. So an inverse function is just a machine that does the opposite of the original function. If the function is something that gets us from point A to point B, the inverse would get us from point B to point A. So let's start with a pretty simple function. So here we have the function y equals 4x plus 2. So again, as a machine, you could say we pick a number, we put that in for x, right? And that machine tells us to multiply that input by 4 and then add 2. Right? So if we plug in a 1, we would have 4 times 1, 4 plus 2 is 6. Right? Put in a 1, we get out a 6. Put in a 3, 4 times 3 is 12 plus 2, we would get out a 14. Okay. To find an inverse function, the first step is to just switch x and y. So we switch x with y, and only the x and y. A common mistake is to switch the whole term. So a common mistake would be putting 4x over here equals y plus 2. But the 4 doesn't go along with it. The only things that we do are just, if we see a y, we put an x. If we see an x, we put a y. So we switch those, and then all we have to do is solve for y. So the steps here, the first thing to get y by itself would be subtract 2 from each side. So we have x minus 2 equals 4y. And lastly, divide by 4. Divide by 4. And I'm going to rewrite it the other way. So we would have y equals x minus 2 over 4. And that's perfectly fine. We don't have to split up that division. It's fine to leave it like that. And let's look at a couple different things here. So the first thing in our original function that we did was multiply x by 4. The last thing we do to that here is divide by 4. So if we multiply by 4 in our original, we should see dividing by 4 in our inverse. The last thing we did was subtract 2, or sorry, add 2. The last thing we did was add 2 in our original. So the first thing we do in our inverse is subtract 2. And just to check it out real quick, if we plug in a 6 down here, we would have 6 minus 2, that's 4, and divide by 4, and it spits out a 1. If we were to plug in 14, 14 minus 2 is 12, divide by that 4, and it does spit out a 3. So our outputs become our inputs of the inverse. So just one other example here. We have the function f of x equals 2x cubed plus 1. And again, the first step is to just switch x and y. Now here we don't see a y, but f of x is the same as y. F of x is another way of writing that output. So we could just replace f of x with y, and there we go. So then we switch x and y, and again, the only things that move are x and y, not the coefficient, so not the 2, and not the exponent. Okay, the exponents stay put. And then we go ahead and solve for y. So subtract 1. So we have x minus 1 equals 2y cubed. Divide both sides by 2. So x minus 1 over 2 equals y cubed. And then what's the inverse operation of cubing something? Well, that would be taking a cube root. So we would need to take the cube root on both sides. And our inverse function is y equals the cube root of x minus 1 over 2. And you could choose a couple numbers to plug into the original. Maybe just start up by trying 1 or 2. See what the outputs of those are. And then swap them and see if it does check out to give you the same value. So that's how we find inverse functions. You just switch x and y. It's kind of like hitting that little button on your GPS or on Google Maps that switches your start and end point. I don't know if you've seen that button, but it swaps your starting and end point, and then you just follow the directions to get back to where you want to go.